in the past. Let's recall certain things. Let's recall some of the formulas that was learned in the past. The first formula is that F is equals to what? Ke. And this formula is what? Is the Hooke's laws formula. Hooke's laws formula. Where this was, where F represents elastic constant and E represents extension. And we said our extension is this length minus old length. So that's why we are basically using it as L1 minus L0 to represent extension. Now, another formula you would also probably come across when you are talking about elasticity is the formula of Young's modulus.
Mr. E.
Young's modulus. There, Young's modulus is talking about what? Stress over strain. And we said that stress is what? Is force over area.
Over area.
While your strain is what? Extension over length.
Extension over length.
Now, another formula you probably come across is that of area. Cross-sectional area. We should know that our cross-sectional area, especially if you have a cylindrical material, is given as pi r squared or pi d squared over 4. Are we following? And another formula we may possibly come across in our calculation in elasticity would also be work done by an elastic material, which is represented as W is equals to 1 all over 2. W is equals to 1 all over 2 Fe, or W is equals to 1 all over 2 Ke squared. So basically, these are the formulas to look out for in your study of what? Elasticity. Where all of these mean their usual meanings. Now, what do I mean by that? F is force in Newton. K is elastic constant. Elastic constant. K is elastic constant, and it's usually given in. Yes.
What is the difference between these two now?
What's the difference between what?
This one.
What?
The two formulas. This one, the Fe and the Ke one. What's the difference?
Substitution. It's substitution. I already said it in it now. Are you not talking about this one yet? Yes?
Yes.
Now, what's the value of F? F is equals to what? Ke. So now, instead of writing F, I used what? Ke. So that's why it is Ke squared here.
Okay.
Good. Yeah, this is your cross-sectional area. Uniform cross-sectional area. Of course, it's a meter squared. And then what else do we have? I think that's all. Okay, L is length. And then when I'm not talking about area, if you want to talk about the area, then your D will mean diameter. Your length is in meters. However, most of the calculations you'll be doing in extension, because they are realistic calculations, most of the calculations will be centimeters, not meters. And R is radius. But because the standard unit of all of these is meters, that is why we are using that. So I believe we are done writing. Let's make it snappy. I'll just give us about a minute to quickly cross our T's and dot our I's. Let's look at the question again. They said a force. Excuse me. I need to make the whole. Now they said a force of 1.8 newtons extend a wire by 0.4 centimeters. What force will be needed, or what force will extend the wire by 1.25 centimeters? Now, for us to solve this question, I always tell people the first thing is that when you have a question on elasticity, particularly the one that require the use of the Hooke's law formula. Most of the questions will be on comparing, or what we call comparison. Now, what do I mean by that? Look at all what we have here. Now, the first we have here is what? Force. They said a force of 1.8 newtons extends a wire by, meaning that your extension is what? 0.4 centimeters. They're not giving a length, and it is not required. Are you following me? Now, they are not asking you what force will extend that wire. So now it's like you're comparing it. It's the same material. Now, they're not saying that what force will extend that same wire. You're not changing the wire. So that means the force constant will be the same. So what will extend that by what? By 1.25 centimeters. 1.25 centimeters. Of course, what do we do from here? Using Hooke's law. Using Hooke's law, which is what? F is equals to what? KE. What we need to do is to obtain our K. Are you getting me? The value of K.
Yeah,
use this first two. Because it's this force that extended it, not this force.
Yeah.
So we use this first two. So that would be what? K is equals to what? K multiplied by 0.4. Which will be what? K is equals to what? 1.8 divided by 0.4. Can we get a... Do you have an answer to it? $1.8 divided by...
I do have calculator. Ada.
Yeah, because and you're in your house. Learning. This is what? It's going to be 4.5 newtons per centimeter. That is the answer. But that is not the final answer we're looking for. What we've only obtained constant. The constant to extend itself. Francis. All right. So that would be what? Therefore, so for this second one, that would be F is equals to what? KE. So now we've gotten our constant. It's a constant. We've gotten that to be what? 4.5. Multiplied by this new extension, which is what? 1.25. What would that give us? So that would be 5.625 newtons. That's the answer. Now, there's also an alternative way of solving this thing. Whenever you discover that the question is a question on Hooke's law and has to do with you comparing. Now, what do we do in this instance? What you just do is this. You just say that, okay, remember that K is equals to F over E, the same formula. Are you following? Now, because this is the first part of it, the K is constant. Constant is, is elastic constant, it's constant. So that means I can say that K is equals to F1 over E1 is equals to what? F2 over what? E2. Because you increase by the same thing. So what do? I would assume that this is F1, this is E1, this is F2, and this is E2. So what would happen? This would be 1.8 divided by 0.4 is equal to F2, which is what we don't know, all over 1.25. So by the time we cross multiply, F2 would be 1.8 times 1.25 divided by 0.4. So your final answer would be 5.625 centimeters. So that will be our answer. So we still get the same thing. So this is an alternative way of solving it because the constant is the same. And that is why for those questions, they always give the condition. provided the elastic limit is not exceeded. All right, so we look at another question. This time around, this question would have something to do with length. It will have something to do with length. So my question is this. A spiral spring extends from a length of 10 cm to 10.01 cm when a force of 20 newtons is applied on it. Calculate the force constant of the spring. Now, what are the parameters we have? Now, the first one we have length, and the second length is what? 10 cm. And the second one we have what? L1, which is what? 10.01 cm. They said a force of what? 20 newtons is applied. Calculate the force constant. Now, ordinarily, we know that from Hooke's law tells us that F is equals to KE. But remember that I can still write this as F is equals to K open bracket. Now, my E, remember E is what? L1 minus L naught. That will be L1 minus L naught, indicating your extension. So from here, I can make K the sum of the formula, and that will be F divided by L1 minus L naught, isn't it? And then my K will be equals to, what's my F? My F is 20 over 10.01 minus 10, which will be 20 divided by 0.01. And what will be my value? That should give us 20 divided by 0.01. 2,000 Newton per centimeter. Newton per centimeters. Please try and get 2,000 Newton per centimeters. Today is 13. 13 plus 4. 13 plus 4. 17 will be on Sunday. Okay. All right, so let's drop this now. Point, the tendon in the man's leg is 0.01 meters long. So that is the length. If a force of 5 newtons stretches the tendon by 2 times 10 raised to the power of minus 4 meters. Minus 5 meters, please. Calculate the strain of the muscle or on the muscle. Calculate the strain on the muscle. That is the question. So let's take a look at the question again. They said the tendon in a man's leg is 0.01 meters long. Now what do we have there? Solution. The length of the tendon is 0.01. Now they said a force of 5 newtons stretches it. The tendon by. They said it stretches the tendon by So that is the extension. They didn't say to, they said by. You have to be careful of the preposition used. So that means our extension is 2 times 10 raised to the power minus 5 meters, which if I decide to collapse it, that would be 0.00002 meters. And then they now asked this question: calculate the strain. Calculate the strain. So we're looking for strain. Now my question is this: what's the formula for strain? Simple. Strain is what? Strain is given as extension over length. That is the formula for strain. Extension over length. So meaning that my extension here is 0.00002 divided by the length, which was given as 0.01. So if you divide those two, if you divide 0.002 and 0.01, what would that give to us? That would be 0.000. Our answer will be what? 0.002. And of course, we know that strain has no units. It has no units.
Is it not when that?
What I said about the difference between stress and strain in our previous video. That stress is as force over area, while strain is what? Extension over what? Length. That stress is as a result of what? I mean, strain is gotten or is obtained as a result of what? Deformation, which is brought about from stress. So stress gives birth to what? Deformation. So we look at the next question. If the stress in a wire is 10 raised to the power of 7 newtons per meter squared, and the wire is stretched from its original length of 10 newtons to 10 centimeters to 10.05 centimeters. Calculate the Young's modulus of the wire. Solution. What are the parameters we have? We have what? Stress. We are giving stress. Of course, stress is force over area, in case you don't remember. At 10.7 meters squared, and the wire is stretched from its original length. So L naught is what? 10 cm. While L1 is what? 10.05 cm. Now you are being asked to calculate modulus. Young modulus is usually denoted with capital letter E. Right. Now remember that Young's modulus, your Young's modulus E is stress over strain. Now in this question, you'll be giving stress. And if you look at it now, you have to be very careful. Look at the unit you are giving, Newton per meter square. But here, you now have what? Centimeters. So that means you have to do a conversion. In previous questions, we didn't convert. Are you following me? But in this case, we need to convert because the unit. Now, what do we mean by that? Now, look at it. Now, I need to do my extension. Good question. I need to do my extension. What will my extension be? Extension is what? L1 minus L0, which is what? 10.05, which is what? 5 centimeters. In the same vein, so now, I now need to do my conversion. 100 centimeters is equal to 1 meter. So that would mean that 0.05 centimeters is equal to x. I cross multiplied it. So x will be equal to what? 0.05 divided by 100, which is 0.0005 meters. That will be your extension. Now remember that we still need to get original length, the value of original length, which is what? Which is 10. So 10 divided by 100, that is 0.1 meters. So that is what our original length is. Now, let's plot it into the formula. Remember that strain is what? Strain is extension over time, over length. Extension over length. So what's our extension in this question? That is 0.0005 divided by our length, which is 0.1. Of course, if we divide that, what would that give to us? That will be 0.005. Remember, it has no dimensions, so you just leave it like that. So now, Young's modulus is stress over strain. And from the question, you're given our stress to be 10 raised to the power of 7, divided by the strain that we just obtained, which is what? 0.005. So I believe our answer should be our answer will be 2 billion. 2 billion Newton per meter squared, or 2 raised to the power of 9. 2 times 10 raised to the power of 9 Newton per meter squared in standard form. I want to believe you got that. So we're taking a final question. The final question would be on work done by an elastic material. Work done by an elastic material. So quickly, let's take that question. Is acted upon by a constant force of 75 newtons. Good stuff. Calculate the potential energy stored by the spring. Okay, this question is talking about work done. Work done being energy. Are you following me? So now, if we look at this is a big question mark. So if you look at this, what our advice would be is we write out our parameters. What are the parameters we have? So the first parameter we have here is that force is equals to what? Force constant, which is K, is equals to 1,500 newtons per meter. And then we have a force of 75 newtons. We have been asked to calculate the potential energy. Our potential energy or the work done. That's what we're looking for now. Now, work done is equals to 1/2 Fe. However, if you look at this question, you're not giving extension. You're only giving force constant and what? And force constant and force. So if you substitute, remember that F is equals to Ke. If you substitute such that E will not be what? F over K, isn't it? So that will be 1/2 multiplied by F multiplied by, instead of writing E now, we are writing F over K. So meaning that this will be 1/2 F squared over K. So if we substitute those values, that would be 1/2 multiplied by F. What's F? 75 squared divided by K, which is what? 1,500. So of course, by the time we calculate this, our final answer would be 1.875. 1.875 joules. 1.875 joules. Do we have questions, comments, observations? In the absence of none, we'll quickly look at one more question before we call it a day. They said a spring of length 25 cm is extended to 30 cm by a load of 150 newtons. Calculate the energy stored. Calculate the energy stored. Now, what are the parameters we have? Let's make it snappy. We have less than 3 minutes. What are the parameters we have in this question? What are the parameters we have? The parameters we have, the first one is what? Length. The length of the spring, 35 cm. And now they now said it is extended to. They didn't say it is extended by. To, meaning that there was an original length, which was 25. And now there's a final length, which is what? 30. And then you have a load, which is force of what? 150 newtons. Are you following me? So meaning that our extension is L1 minus L0, which is what? 30 minus 25, which is 5 cm. So of course, if we are converting this, this will be 5 divided by 100. That will give us 0.05 meters. We need to convert it because joules is a what? Joules is making use of force times distance, and that distance is a meter. So therefore, that will be F. That will be your work done is equals to 1/2 Fe. That will be 1/2 multiplied by F, which is what? 150, and multiplied by our E, which is 0.05. Now, if we try to calculate this, this will be 3.75 joules. That's our answer. 3.75 joules. That is our answer. Thank you for listening to this video. You're welcome.